Hello, I'm Bill Kinney. This is video number 41 in my series on the foundations of arithmetic, algebra, and graphing, with a focus on real-life interpretation and application. It's part 10 of a sub-series on exponents, roots, and logarithms with an emphasis on calculator usage. I started very briefly talking about logarithms in the last video, and I don't want to delve too deeply into logarithms, so I'm hoping that I can finish this in this series with this particular video. I can find my paper here. If that takes too long, I might not be able to do it. I tried to motivate the idea of a logarithm as a way of representing a solution to a problem like this. Mosquitoes are growing by a factor of 10 every month. Ultimately, how long will it take for them to grow by a factor of 40,000? And if you review that video, the key equation we want to solve is this one. And I use the logarithm button on my calculator to solve it. You would write this notationally as x equals log of 40,000, and take note of the way that I said that as well. The x, the unknown that I want to solve for this in this equation, the unknown exponent, symbolically it's written this way, and you say x equals the log of 40,000. And then when you type it in the calculator, if you've got a calculator like this, you type in, hit the button that says log, and then you type in 40,000, and it was about 4.602. If I want to check it, I take 10 and raise it to that power, and I get 40,000. Now, just a plain log like this is often called a common logarithm. Technically speaking, you only use the common logarithm symbol when this number right there is 10. It is also okay to write log with a subscript of 10 of 40,000. When you see that subscript of 10, that emphasizes that the base of this expression is 10, and you will sometimes say it's log base 10 of 40,000. Another name for this log base 10 is the common logarithm. But I want to just briefly introduce you to the fact that there are other kinds of logarithms, and ultimately we'll use those other kinds of logarithms to help us solve a problem or two. I'm going to go pretty quick. You might need to watch this video twice to really get it. Say I want to solve this equation. It's actually not too hard to solve. Guessing helps you see that the unknown x equals 5, because since 2 to the 5th equals 32. 5 there can also be written. Notice this is similar to the equation 10 to the x equals 40,000. The unknown is in the exponent. The x, the answer, which is 5, can also be written as a logarithm. We can also write x equals log base 2 of 32. And since 2 to the 5th equals 32, we say log base 2 of 32 equals 5. 5 is the answer, but we can also write it symbolically like that, and if you think back to the other example, it's very similar. The other example I wrote log of 40,000, or log base 10 of 40,000, was approximately 4.602. Here we're saying log base 2 of 32, which comes from a similar equation, equals 5. 5 is the unknown exponent. What's the answer to this one? Symbolically, we can write it as log base 3 of 81. And that symbol means the answer to this equation, what's this unknown? What number can we put there that will make 3 to that number equal 81? The answer is 4. Try an even trickier one here. 16 to the x equals 1/4. What if I wanted to solve that equation? Symbolically, you can write it as x equals log base 16 of 1/4. as far as answering it, we're looking for the exponent, so that if I raise 16 to that exponent, I'll get 1/4. That's a bit tricky. If this were a 4 there, instead of a 1/4, if you think about it, the answer would be 1/2, because 16 to the 1/2 power is the square root of 16 is 4. What is it if it's going to be a 1/4? Think about it. Maybe pause the video and think. See if you can figure it out. Are you back now? The answer is going to be -1/2. Since 16 to the -1/2 is 1 over 16 to the +1/2, 1 over the square root of 16, which is 1/4. Gets trickier, much trickier, if you've got something very different, like, say, that. I purposely picked a number here that's not a whole number power of 2, and in fact, if you think about it for a long time, you'll realize it's probably not even a fractional power of 2. You could write the answer symbolically as log base 2 of 20, but that doesn't help you figure it out. It's got to be something between 4 and 5, but what is it exactly? Well, actually, it's going to be an irrational number. We're only going to be able to approximate it. And let me just tell you the trick. I'm not going to explain the trick for using your calculator. I'm not going to explain why this trick works. What you do is you take the common logarithm, log base 10 of the 20, and you divide it by the common logarithm of the original base 2. I'm not going to explain why that works, but that is the method. Whatever number is here, and in general, I'll write it like this. If you want to solve that kind of equation, you can write the answer symbolically like this, and as a practical use on your calculator, you can write it like this. I'm not going to tell you why. Anyway, let's do that on the calculator. Up here, log base 10, common logarithm of 20 divided by logarithm of 2. I can type it in like this. Oops. Log of 20 divided by log of 2. It is between 4 and 5. 4.32. If I take 2 and raise it to that number, I get 20. It worked. Let's finish off this video by applying that idea to a couple examples. This example we looked at a number of videos ago. If you have a CD that's paying 2% interest, about how long will it take for your money to double? The answer was about 35 years, we saw. The key thing we're trying to solve ultimately is this equation. What value of x will make 1.202 to the x equal to 2? And I put a 2 there because that's going to then double whatever amount of money you start with. And the answer based on logarithms is going to be based on what I did in the previous page. Log of 2 divided by log of 1.02. Try it in your calculator, you should get about 35. Give that a try. One more example. If your money is growing by 2% per year, how long will it take to grow by 50%? Instead of doubling, growing by 100%, grow by 50%. To grow by 50% means you're going to multiply the original amount by 1.5. So we need to solve this equation based on the logarithm trick I've shown you here. The answer would be log of 1.5 divided by log of 1.02. We'll do that on the calculator together, and that'll be the last part of this video. Log of 1.5, parentheses here as I'm using them are absolutely necessary, divided by log of 1.02. Well, I don't need an end parenthesis there, but I'll put one anyway. About 20.475. That's how long it's going to take your money to grow by 50%. When I do this, I think about it, I should get 1.5, and I do. Okay, so you probably want to watch that again if you felt like it was just too rushed, but that's what I wanted to teach you about logarithms.